Hi, chemistry students. So now that we know how to determine whether a molecule is polar or not, and we know how to determine what kind of forces exist between different kinds of molecules, now we can kind of look at how those interactions affect the state of matter that pure forms of these molecules exist in. And so if you take a look at our picture on the slide that you see here, we have the three states of matter: gas, liquid, and solid. Gases are made of molecules that have very high energy, and so the molecules are zooming around. They have lots of space in between them. And because they are so spread out, they are not going to have very strong interactions with each other. And so they are going to have very weak intermolecular forces between those molecules. In a liquid, though, you still have some pretty energetic molecules, but they are a lot closer to each other than they are in the gaseous state. So they're going to have more of like a medium strength type of intermolecular force. But the strongest intermolecular forces are going to exist in solids because those molecules are packed very closely to each other. They don't have a lot of energy. They're not moving around a lot. And so they're going to have some very strong interactions in between them. All right, so let's say that you have a question that says, what kind of intermolecular force exists between two molecules of hydrogen fluoride? So the first thing you have to do is draw the electron dot diagram. You need to basically you need to figure out, is hydrogen fluoride polar or nonpolar? Right? We have one bond in there. Once you figure out whether the intramolecular bond, the bond between the hydrogen atom and the fluorine atom, once you know if that's polar or nonpolar, figure out the partial charges, and then you can determine if the whole molecule is polar or not. Remember that if the molecules are nonpolar, then the only intermolecular force, the only IMF that can exist between them is dispersion. If they are polar, but they don't have any hydrogens, then that's going to be dispersion and dipole interaction. If they are polar and they have a hydrogen attached to fun, then they are going to have dispersion forces and dipole interactions and hydrogen bonds. They're going to have all three. So dispersion is going to exist between all molecules. Dispersion and dipole are going to exist between molecules that are permanently polar but that don't have a hydrogen attached to fun. And if the molecules have a hydrogen attached to fun, they're going to have all three: dispersion, dipole, and hydrogen bonds. So you would have to indicate that all three of those intermolecular forces exist between two molecules that have a hydrogen attached to fun. Okay, so if we're looking at which type of IMF occurs between two molecules of hydrogen fluoride, well, then this is what we've got to do. So here is our hydrogen and our fluorine atom. And hydrogen has an electronegativity value of 2.1, and fluorine has an electronegativity value of 4.0. And so when we subtract these two with our absolute value bars, we are going to find that we have a difference of 1.9. Which means that our bond is going to be polar covalent. So if our bond is polar covalent, let me just draw that again. Here is our HF. If it's polar covalent, that means that our electrons are going to be pulled towards the fluorine because that's the atom that has the higher electronegativity value. and that over here we're going to have our partial positive charge. And can I draw a line that separates my positives and my negatives? Yes, I can. And so if I look at this, this is a polar molecule. And does it have a hydrogen? Yes, it does. It has a hydrogen. And is the hydrogen attached to F, O, or N? Yes, it is. So if I have another one of these molecules, like so, here's my HF over here, like my second molecule. And let me erase that. And here are my dots. Okay, so there's my second molecule. I'm going to erase my line here. And there's my bond. Okay, and so my hydrogen is going to be attracted to one of the unshared electron pairs on the adjacent atom. So this is going to be a hydrogen bond. This is a dipole interaction because my molecules are permanently polar, and it's going to have dispersion forces also, because dispersion forces are going to occur between all molecules. So that's an example of like a molecule or like two molecules that would have all three intermolecular forces together. And so that's pretty much a summary of what I just went over. Okay. So what about the intermolecular force that exists between two molecules of oxygen? Well, my oxygen is going to look like this. So O2 looks like this. And my oxygen is going to have an electronegativity value of 3.5. And both of them have an electronegativity value of 3.5. And if I subtract them, that means that my electronegativity difference is going to be 0. And if there's no difference, then that means that they are sharing electrons equally. And so this is a non-polar covalent bond right here. And so since this is only one bond, that means that this is a non-polar molecule. And if I had another oxygen molecule off to the side here, they would be attracted to each other, but this attraction would be a dispersion force only. And the reason why it would be dispersion only is because dispersion is the only kind of intermolecular force that exists in between two molecules that are nonpolar. And so this is the summary of what I just did here. All right. So let's go over some questions here. So which type or types of intermolecular forces exist between two permanently polar molecules that contain hydrogen and nitrogen? So the clue here is that they are permanently polar, we have a hydrogen, and it's attached to N, which is a part of fun. So what this means is that our answer is the one that is here at the bottom: dipole, hydrogen bonding, and dispersion. It's going to have all three. Okay, next question. Which type or types of IMFs exist between two nonpolar molecules? Think about it. We just did an example on this. If you said dispersion force only, then you are correct. Dispersion forces are the only IMFs to exist between two nonpolar molecules. Next, which type or types of IMFs exist between two polar molecules that do not contain hydrogen? So now here's your clue. No hydrogen, and yet they're still polar. All right, if you guessed dipole and dispersion, then you would be correct. So dipole because they are polar, and dispersion because dispersion exists between all molecules. But you shouldn't have chosen hydrogen bond because there's no hydrogen in this molecule, and you've got to have hydrogen in order to have hydrogen bonding. Okay, and that is it for this slide deck. All right, thank you for watching, and I'll see you again soon.